Hey y'all, it's your main math teacher, Mr. Boyd, and back at it again, because today we're going to be dividing polynomials via long division and some synthetic methods. Okay, for today, there's a couple key concepts and a couple key skills. To make sure that what we're going to do is going to make sense, we need to start out with this really basic intro question. So this would be a great one for you to pause the video and take a minute or two thinking about yourself. We're going to write down the equation of a polynomial, which is going to have zeros at -1, 3, and 5. So what I'd like you to think about in order to kind of break into that is, what characteristics would an equation have to have so that it produces zeros at -1, 3, and 5? Okay, here at a bare minimum, here's what would have to happen. Okay, in order to get -1, you would have to have as a factor x plus 1. So then you'd look at it and say, oh my gosh, yeah, the 0 would be -1. Now, if you didn't get that at first, but that jogged your memory, go ahead and deal with the 3 and the 5 now. You may have to pause to do that. Okay, for the 3, at least you're going to have something like x minus 3. And for the 5, you're probably going to have something like x minus 5 in there. So certainly what we've written here does it. That's a cubic polynomial that has that. If you wanted to increase the degree, like let's say you wanted the degree to be 7, how would you do that? Okay, remember, degree is the sum of the multiplicity. So what you could do is you could slap a 5 on there. And then we know these are 1s. That's a 1, and that's a 1. And 1 plus 1 plus 5 would be degree 7. What if you wanted it to be degree 17? Well, what you could do is you could make that a 10, and that'd be 10 plus 5 plus 1 is 16. Well, we'd probably have to make that a 2 then. So then you can just play with the exponents to get your multiplicity. Okay, so with that, let's get into our skills. We've got a base concept, we'll get some skills, and then we'll put the two together. So you may remember back from elementary school that we did long division. Okay, we're going to do the same thing today, but it's with polynomials. And believe it or not, I actually think that this is a little bit easier. Just a little side note here, you always want to put the exponents in descending order. Why is that? The reason for that is if I say 520 or 523, you know that number is 523. It's not 235 or 532. We read the numbers in order from each place value. So instead of place values for digits today, we're going to have an x squared's place and a 3x's place and a 5's place. Okay, the long division looks like this. Put the x plus 1, the thing we're dividing by, on the outside. The thing we're dividing goes on the inside. And then the way we think about it, we ask ourselves, x times something would be x squared. What would that something have to be? That something would have to be x. Then we will always multiply what we chose by this original expression. So x times x is x squared, and x times 1 is x. And you may recall from elementary school that we then always do subtraction right here. So let's do that. X squared minus itself, goodbye. 3x minus x is 2x, and then we bring the 5 down. Okay, now that's the process. And so what we're going to do is we're just going to rinse and repeat that until we can't anymore, the same way we did back in about 4th grade. Okay, so again, now we're asking x times what would be 2x? Well, that would be 2. And then we multiply the 2 by what we're dividing by. So 2 times x plus 1, that would be 2x plus 2. Now we're subtracting. Please use parentheses so you recognize that everything is subtracted. That's a really common mistake for new learners. Okay, the 2 minus 2 cancels out. You have 5 minus 2 is 3. Now back in elementary school, I'm willing to bet that you called that a remainder. So if you had a question like this, you would say 3 goes into 8 how many times? It goes in twice with a remainder of 2. You probably did that. Okay, so what that really means, that 2 remainder 2, it really means 2 plus 2/3, or 2 and 2/3 as a mixed number. Okay, so we're going to represent that the same way here. It's not remainder 3. It's that we have a leftover 3 that's still being divided by x plus 1, but we don't know how to do that. And so what we have is 3 over x plus 1. Okay, so there is our, well, for now, we'll call it our answer. Okay, so that's the basic skill that we're going to be using today. Let's talk about why we're doing that, because that might seem really strange that we're doing that in a high school level class. Okay, the reason is because the polynomials we've done so far that we've tried to graph, they've all been factorable. However, there are many polynomials which either are not factorable or it's really, really difficult to factor them by traditional methods. So what we're learning a little, it's not really a shortcut, but sort of a little trick that's going to help us factor and find zeros. So here's what you got to know. An expression is only a factor if the remainder is 0 when we divide it. Think about it with numbers. Maybe that'll make more sense. Take a number like 30. If you divide that by 7, does it divide evenly? No. That means 7 is not a factor of 30. What about if you took 30 and you divided that by 5? You'd get 6. And what that would tell us is that 5 times 6 is 30. So 5 and 6 are both factors. Okay, so for numbers, it's kind of easy. Like for 30, we could make a factor tree. Like we could do 10 and 3 and break that into 5 and 2. So then we know 5 times 2 times 3 is 30, or 5, 2, and 3 are the different factors of 30. It's much more challenging to do with polynomials, which is why we're going to use this trick. Okay, let's see a little bit more about how to do it and how it works. So we have an example now where we're explicitly talking about a polynomial and we're talking about finding the zeros of it. So notice right away, looking at this, can you factor it? Okay, is there anything that all the terms have in common? No, not really. Is there anything that all those coefficients are divisible by? No, not really. And so we're going to try this trick. We're asked, hey, is 2 a 0? If it is, find all the zeros. So what we're going to try to do is divide out a factor that would make 2 a 0. Now this goes back to where we started. If 2 is a 0, x minus 2 is a factor. And if it is a factor, whoops, what happened there? If it is a factor, then that means it will divide evenly. We'll have a remainder of 0. So let's test it and see if x minus 2 truly is a factor. Here we go. So I'm going to set it up like this. X minus 2. And what are we dividing? We are dividing 6x cubed minus 19x squared plus 16x minus 4. Now, if you're feeling like you already understand how to do long division on a polynomial, then by all means, go ahead and see if you can get this one right by yourself. If you're not feeling too good about it, or if this is brand new, today's the first day you've seen this, might be better if we stuck together for 1 or 2 more of these. Okay, let's give it a shot. What we're wondering is, what would we multiply x by to make it 6x cubed? That'd probably be 6x squared. Let's distribute this down. So we get 6x cubed minus 12x squared. Subtract. And so we get something minus itself, which, by the way, if that doesn't happen, you've made a mistake. Okay, and here we have negative 19 minus negative 12. Negative 19 minus negative 12. That's like plus 12. So that's negative 7x squared. Now be careful. I noticed in class many students put positive 7 right here, but that's a negative 19 we're dealing with, so that's now a negative 7. Okay, let's pull these down. So plus 16x minus 4. All right, rinse and repeat. Notice every time we do that, we drop the degree down by 1. So let's do it again. What would we multiply x by to get negative 7x squared? Probably negative 7x. Let's distribute it back. So we get negative 7x squared plus, because we're doing minus a negative, plus 14x. Subtract. Here we go. And we get 16x minus 14x. That would be 2x. Bring down the minus 4. So we get 2x minus 4. How would you turn an x into a 2x? You probably multiply that by 2. So then you get 2x minus 4. Hey, look at that. We end up with something minus itself. So that's 0. What does it mean? Let's go back to the question. Is 2 a factor, or is 2 a 0? Yes, because the factor that comes from it divided evenly with no remainder. So yeah, it absolutely is. Now, here's what that means. That means another way of writing f of x is x minus 2 multiplied by this guy. Okay, multiplied by 6x squared minus 7x plus 2. So this is why I'm saying this is a trick to help us factor. We've used this little piece of information and our skill of long division. We actually have factored this polynomial into something linear and quadratic. So we look at that and we go, hey, nice. So that is a 0 at 2. Great. What are the others? We're going to find the others. How do you factor this? We're probably not going to. We're probably going to use the quadratic formula. So this is another good chance for you to pause the video and review that skill. Here I go. X equals negative b. It's already negative, so we're going to make it positive. Over 2a. 2 times 6 is 12. Plus or minus the square root of b squared. B squared is negative 7. Square it. You get 49. Minus 4ac. Let's do some mental math. 4 times 6 times 2. 4 times 6 is 24. times 2 is 48 over 2a. We already know what that is. It's 12. So let's keep going. 7 over 12 plus or minus. All right, y'all, we're doing a little bit more mental math here. 49 minus 48 is 1, and the square root of 1 is 1. How incredibly convenient. And then we get a 12 right there. So now we get to do 7 plus 1/2, or excuse me, 7 over 12 plus 1 over 12. So we get 8 over 12, which simplifies to 2/3. That's one of the zeros. And we also have to do 7 over 12 minus 1 over 12, which is 6 over 12. So we'll show that this split. 6 over 12, which is the same as 1/2. So let's go back to the question. Is 2 a 0? Yep. Find all the others. Here they are. 2/3 and 1/2 are the other two. Okay, so that's our little trick. Let's practice a little more. Okay, what about this one? What I want to show you now is some of the things, some of the ways that you can be tricked, or some of the traps you can fall into. So is x minus 1 a factor of x cubed minus 1? Let's see. If it is, it'll divide evenly. So let's divide it and see what happens. So x cubed minus 1. All right, how would you turn an x into an x cubed? Probably with an x squared. Multiply it back and get x cubed minus x squared. Some students get a little flustered right here because they say, okay, nice, that cancels, but I can't combine those. That's totally fine. Now remember, we want to operate on them in descending order, which means I'm going to start with the one that's squared, not the one that's a constant. So when I say descending order, I mean the degree. This has degree 2, that has degree 0. Okay, so minus a negative, that would be x squared minus 1. Rinse and repeat. So x times something is x squared, that would be x. And let's see, x times multiplying that back, so that'd be x squared minus x. Subtract it. Cancel. Minus a negative x would be the same as a positive x, and we bring down the minus 1. What would you do to turn an x into an x? I wouldn't do anything. I multiply it by 1. Okay, 1 times that, I get x minus 1. We're subtracting, so I get 0. So, is x minus 1 a factor of x cubed minus 1? Yes. And we know that because we can write it in a factored form as x minus 1 multiplied by x squared plus x plus 1. Cool. So that worked. So even if they're missing some of the terms, and when I say missing, I mean it's like a 0x squared and a 0x. That's okay. We just honor the process and combine like terms. Not a problem. Okay, what about this one? Maybe you're ready to try to set it up by yourself. Okay, there absolutely is a trap here. Okay, the trap is this. I said they have to be in descending order of power, and we have flipped these. So in order to do your setup, you'll need to flip them back, like this. So you'll write this as 3x cubed minus 2x squared plus 2x minus 1. Okay, and now you're probably ready to roll through this one on your own. I think you probably can handle it. So go for it. So all we're going to do, we're going to say x times something is 3x cubed. So that would be a 3x squared. Multiply it down. We get 3x cubed minus 9x squared. Make sure you understand that you're subtracting. Canceling. Negative 2 minus negative 9 would be 7. So 7x squared. How do you get a 7x squared up here? You're going to make a 7x, because then 7x times x is 7x squared. And look at that. I've gotten a little bit lazy. I probably need to pull these down. So plus 2x minus 1. And then we're going to do the 7x times the negative 3, so minus 21x. 7x's cancel out. So I have 2x minus negative 21x. That'd be plus. So that'd be 23x minus 1. And then, how do we turn an x into a 23x? We multiply it by 23. So now we have 23x. And we do 23 times negative 3, or minus 69. Subtract it. Be careful when you're subtracting a negative. We have negative 1 minus negative 69. That's like plus 69. So this is 68. So we have to make sure we answer the question in responding to the way it was asked. So they asked us to do division. So what's the answer? Okay, the answer is this thing up here, but you also include your remainder. Do not say R68. What we're going to do is we're going to say plus 68 over x minus 3. And now that's done. Okay, so At this stage of the game, you're probably feeling pretty good about how to do long division with polynomials, and you might think it's easy and fun, and you might think it's easy and boring, or you might think it's hard and boring. If you had to do like 50 or 60 or 70 of these, it might start to feel kind of tedious. Doing 2 or 3 is not so bad, but doing a bunch of them, that's going to be kind of rough. And in our next lesson, we're actually going to see why we would need to do it a bunch of times over. And so we need to look for an easier way to do this division. So are there any symbols on the screen that are unimportant to getting these answers? There absolutely are. The fact that we wrote these x cubes, it's really not doing anything, because I've organized my work well enough that all the x cubes are lined up vertically. The x squareds, is writing those really doing anything? Not really. I've got them lined up vertically, they're all together. I wasn't even really thinking about it when I wrote them, they're just there as placeholders. What about all the x's? Are they really doing anything? Not really. They're all lined up vertically. What about these constants? They're all lined up. Okay, now guys, that's the same idea as back like in elementary school. Your teacher probably taught you that to do addition, you had to line up your decimals. If you have like 3.5 and 27, and maybe you'd throw a 0 on it, you have to line up the decimals. That's essentially what we're doing here. And because we've done that, we get to do a little trick that's called synthetic division. Okay, here's how synthetic division goes. What we're going to do is we're just going to use numbers. We're not going to use any variables at all. So we're going to pull the number that makes that 0. That would be 3. And we're going to build a box around it. Then we're going to pull off all the coefficients, and we're going to do it in order. Okay, so order from greatest power to least. So 3, and then -2, and then 2, and then -1. Okay, and then here's what happens. The process looks like this. What you do is you multiply, and then you add, and then you multiply, and then you add. And you just keep doing that until it's done. Here's what I mean. Okay, what we're going to do, we're first going to pull this 3 down. And we're just going to write it. Then we're going to multiply. What are we going to multiply by? We're always going to multiply by the number in the box. Okay, so times 3. 3 times 3 is 9. Then we're going to do addition, just like back in elementary school. Like I'm talking first grade style, y'all. Okay, so -2 plus 9 is 7. Then we're going to multiply. Okay, we're going to multiply 7 by 3 and get 21. So multiply, add, it's time to add. 2 plus 21 is 23. And then we're going to multiply by 3. And we're going to get 69, and -1 plus 69 is 68. Now you may have noticed this midway through. These numbers are all the same answers from our question. 3, 7, 23, 68. 3, 7, 23, 68. So what I like to do at the end, that number at the end, I usually put it in a box. That number is always the remainder. This number is always a constant term. As we count to the left, the next one will be linear. The next one will be quadratic, so x squared. If there were another term, what would it be? Well, just keep counting up the powers. It would be x cubed. None of them are negative, so we're going to put pluses in between them. Now, do you notice that's the exact same answer? And y'all, when I saw this in 11th grade, I thought that was magic. I mean, really, I thought my teacher was a magician. But the deal is, it's all the same stuff that we've been doing all along. Notice right here, like we ended up with 2 plus 9, excuse me, -2 plus 9. We have -2 plus 9 right there. Okay, where'd the 3 turn into the 9? Right here. Okay, we had 3 times 3, it made a 9 right there. Same thing. It's just hidden in a bunch of muck here, and it's out in the open over here. What about here? We had 2 plus 21. Yep, we did that over here too. What about the -1 plus 69? Yep, did that too. Okay, it's all the same steps. It's just a lot less work. So what we're going to do now, we're going to go back up to the top. We're going to run through all these examples again in about 15% of the time. Okay, so I'm going to go back up to the very first example. Watch how quick this is now. It takes almost no thinking. Okay, here's what all I do. I take this, I ask what makes it 0. What would make it 0 is -1. Build a box around it. Take the coefficients in order. 1, 3, 5. Pull the first one down. 1. Multiply, -1. Add them, 2. Multiply, -2. Add them, 3. 1, 2, 3. 1, 2, 3. It's the same thing. Remember, that's the remainder, so we're going to put it over x plus 1. The next one over is always a constant. The next one over is linear. We just keep introducing higher level powers, and so look at that. That matches exactly our answer. Okay, let's do the second example. Second example, we were asked if 2 is a 0. Okay, let's see how it works on this one. See if it works just as well, just as easily. Notice how much space this took and how little space I'm going to use now. Let's pull the coefficients. They want to know if 2 is a 0. Okay, we're going to plug in a 2. Coefficients, 6, negative 19, 16, negative 4. Okay, pull the 6, multiply, add, multiply, add, multiply, add. Remainder is 0. Is 2 a 0? Yes. See how quick that is? It's a lot faster than going all the way through long division. So long division works every time. Synthetic division works every time too, because it's the same thing, and it's just a little bit faster. Now there are a couple ways it can go haywire. Okay, and so one of the ways, the most common way actually that people have mistakes, is with a question like this one. Okay, so what a lot of people will do is they'll say, all right, is x minus 1 a factor? That means 1 goes in the box? True. And then they do this. They put a 1 and a 1. And the reason that doesn't work is the same reason why this number is not 1001. Okay, now if you wanted to write 1001, you'd have to write 1, 0, 0, 1. But what are the zeros doing? I mean, because 0 doesn't have a value, right? But 0 is a placeholder, okay? And so it's important. It's going to hold that spot down so we recognize the number as 1001. So what you're doing here, you're putting a 1 for x cubed, but you have to say 0 x squared, 0 x's, and then at the end, there's a negative 1. Okay, so you have to put those in or it's not going to work. Okay, and so let's pull the 1. So pull the 1 down, you get a 1, times 1 is 1, add them together and get 1, times 1 is 1, add them together and get 1, times 1 is 1, well, that's a lot of 1s, and then add them together and get 0. The remainder was 0, the answer is yes. So this is plenty of work, okay, to demonstrate that yes, it is a factor because the remainder was 0. And that's going to be useful for dealing with a question like this one. It's going to save us minutes, really, as compared to long division. So let's go through it. We're told that 2 and 3 are roots of this polynomial, okay, and we're asked to find the others. So if these are roots, that means we can divide them out evenly. I want to show you what happens when we do that. Let's start with 2, okay, and then pull the coefficients. So 2, 7, negative 4, 27, negative 18. Now, y'all, do you know what number is going to be in this box at the end? You should, because they told us that these are roots. So what that means is that this has to be a 0. Let's see if that works out. Okay, we're going to pull the 2, multiply by 2, add them together. Okay, we're going to get 11. Multiply by 2, add them together, 18. Multiply by 2, 36. And it looks like, you know, it looks like I forgot that negative. Let's put that in. Okay, add them together and get 9. Times 2 gives us 18. And now, negative 18 plus 18 is 0. All right, so that worked. Okay, so that doesn't seem too interesting, though. We already knew that was going to work, so what's the purpose? Okay, notice right here. We started with something that was 4th power that was not factorable. What do we have now? Okay, that's a constant. That's x squared, and that's x cubed. So we've used information to reduce a 4th degree down to a 3rd degree, and then this one will reduce even further. So let's use the negative 3 now. And here's the other mistake that a lot of people make. They will pull off these same coefficients again. But there's a problem with that. If we start with another 4th degree, it's just going to drop down to a 3rd degree, and we won't know how to factor it. But if we pull these exact coefficients of the cubic, so 2, 11, 18, and 9, then we will get out something that is quadratic. So we already know that's a 0. We're told that it's a root. So let's use that to our advantage to make sure we don't make any mistakes. Okay, pull the 2, multiply, add, multiply, add, multiply, and look, it works out like we thought it would. So the thing that I didn't understand when I took pre-calculus, I would see all these numbers on the page, and really I had no concept of what they meant. Y'all, here's what it means. Okay, 2 divided out evenly, so x minus 2 was a factor. Okay, negative 3 divided out evenly, so x plus 3 was a factor. And what's left over? 2, 5, 3. Okay, so no remainder. We have a 3, which means that's a 5x, and that's an x squared, which means that we actually have factored this. So 2x squared plus 5x plus 3. Okay, let's see. What are the other zeros? Okay, we know that's 2. Well, we already knew that. They told us. And we know that's 3. Okay, well, we already knew that. They told us. Let's find the others. How do you find zeros out of here? Let's quadraticize it. Okay, negative b over 2a plus or minus square root of b squared minus 4ac. Okay, 4 times 2 is 8 times 3 is 24 over 2a. Simplify it. Don't forget to know that that's x. Okay, so negative 5/6. 25 minus 24 is 1. Square root of 1 is 1, so plus or minus 1/6. All right, so negative 5 plus 1 is negative 4. And negative 5 minus 1 is negative 6. So that simplifies to negative 1. That's one of the zeros. And that simplifies to negative 2/3. That's another one of the zeros. Okay, so we've used an example now where we had a 4th degree and we were able to find all the zeros because we knew a couple of them. Okay, so that's pretty much the extent of what we're going to do for today with long division. There is one other thing that this process will allow us to do though. Okay, and that's synthetic substitution. So to see what that is, I'd like you to pause for a moment and I'd like you to complete this table for these x values. So plug in a negative 1, plug in a 0, plug in a 1 and a 2, and let's see what you get. Okay, and I'm going to take a minute and do that as well. Okay, so it looks like I plug in a negative 1, I get 1 minus 2 plus 5, so 4. Plug in a 0 and I get 5. Plug in a 1 and I get 1 plus 2 plus 5, so 8. And plug in a 2 and it looks like I get 4 plus 4 plus 5, so I get 13. Okay, now that's not too interesting or too hard. I mean, we do that in Algebra 1, right? But here's what I want to show you. Okay, what if we had done that with a synthetic process? What would have happened? Okay, coefficients are 1, 2, 5. 1, 2, 5. Okay, pull the 1. Multiply. So negative 1. Add them together, and you get 1. Multiply by negative 1. Or excuse me, yeah, by negative 1, and you get negative 1. Add them together, and you get 4. Interesting. Let's try it with 0. 1, 2, 5, same coefficients. Pull the 1. Times 0 is 0. Add them together and get 2. Times 0 is 0. Add them together and get 5. Interesting. What if you plug in a 1? Coefficients are 1, 2, and 5. Okay, bring down the 1. Multiply by 1 and get 1. Add them and get 3. Multiply by 1 and get 3. Add them and get 8. Interesting. Let's put the 2 in there now. 1, 2, 5. Okay, 1 times 2 is 2. Add them together and get 4. Times 2 is 8. Plus 5 is 13. Interesting. So, what does it all mean? This number that pops out at the end, it's a remainder. Yeah. But it is also a y value. And in some ways that should make sense. Notice we were looking for when it would pop out a 0. Okay, so like they said this is a root of the function, which means it's a 0, which means the number that pops out needed to be a 0. So it's not super surprising that that's a y value necessarily. And with that, we can answer questions like these. Okay, and I think there's a negative down here. Yeah, there it is. Okay, so we can answer questions like these. So rather than having to plug in a negative 3 and cube it and wonder if it's positive and negative, we can run through the synthetic process. Let's do it. If you want to pause the video and set it up on your own, that'd probably be a good idea, and see if you can get it right. Okay, 1 goes in the box. What are my coefficients? 2, 0, there's no x to the 4th term, negative 25, and 2, negative 12, and 7. All right, here we go. Okay. Pull the 2, multiply and get 2, add them together and get 2, multiply by 1 and get 2, add them together and get negative 23, multiply by 1 and get negative 23, add them together, get negative 21, negative 21, add them together and get negative 33, multiply by 1 and get negative 33 again, add them together and get negative 26. Okay, so with that one, when it's 1, it doesn't necessarily save us a ton of time. Let's see what happens with 2. 2 works the same way. Okay, same coefficients, 2, 0, negative 25, 2, negative 12, and 7. All right, we're going to cruise through this thing. Pull the 2, multiply by 2, and you get 4. Add them and get 4. Multiply and get 8. Okay, negative 25 plus 8 Got to think for just a second. I think that's negative 17. Okay, multiply by 2 and get negative 34. Add those together and get negative 32. Multiply by 2 and get negative 64. Add those together and get negative 76. 76 times 2 gives us negative 152. And then when you add that to 7, looks like we get negative 145. And what about for a negative 3? Same coefficients. Let's see what we get. Okay, 2 comes down, times negative 3 gives you negative 6. Add them together, you've still got negative 6. Multiply again, 2 negatives make a positive, so that's 18. Add them together and get negative 7. Multiply and get 21. Looks like we're at 23. Multiply again, and we have negative 69. Minus 12 gives us 81. Times 3 again, make sure it's negative 3, and you get negative 243. And then add that 7 on there, and you get negative 236. Okay, so for some of these, it's a little bit of a shortcut that makes it a little bit easier than having to keep track of all these exponents and whether they're positive, whether they're negative. It's all taken care of in the process for you. Okay, so after today, you should be able to factor many, not all, we'll work on that next time, but you should be able to factor most polynomials and sketch them, finding the zeros by either long division or synthetic division. Okay, if you've enjoyed the video, and we'll see you next time.